Many quantities change with time, and there are various ways in which we describe these changes. Often, we want to describe how much something has changed not as an absolute amount, but in relation to its original value. Why? Well, for example, suppose that yesterday a TV cost $395 and today it costs $400. Then the price has increased by $5. And that's not a very big price increase to go from $395 to $400. On the other hand, suppose that yesterday a candy bar cost 80 cents and today it costs $5.80. The price has still increased by $5. But in the second story, that $5 is a much bigger price increase. Why? Because this one started off costing 80 cents, and this one started off costing $395. When we want to describe a change in some quantity in relationship to the starting amount, one of the things that we use is the idea of percent change. The percent change in a quantity is the amount of change, either an increase or a decrease, expressed as a percent of the starting amount. Now this is key, as a percent of the starting amount. Always, when we're talking about percent change, the starting amount, not the final amount, is the base. The reason for that is we always think of percent change going forward in time. So we always change from the starting amount by some percent of the starting amount. So for example, when the price goes from 80 cents to $5.80, an increase of $5, then as a percent change, we have the amount change over the starting amount is the percent change over 100. In this example, the amount change is $5. The starting amount is 80 cents, and that should equal the unknown percent change over 100. Cross multiplying, we get 500 is 80 cents times P, dropping the trailing zero now. So P should be 500 divided by 0.8. We don't like to divide by decimals though. So moving each decimal point one place to the right, 5,000 divided by 8. Let's do that division off to the side. 8 goes into 5, not at all. It goes into 56 times. 8 goes into 20 twice. It goes into 40 5 times with nothing left. So this comes out to exactly 625. So this represents a 625% increase. And notice that this is more than 100%. Why? Because the amount that the price went up is more than the entire starting price. We understand this 625% not as a part of a whole as such, but rather as a ratio. The ratio of the amount that the value changed by to where it started from. Because the value changed by more than its starting value, this is more than 100%. Now, of course, we can describe either an increase or a decrease as a percent change. If we saw an increase, the starting amount is less than the final amount. If we saw a decrease, the starting amount is more than the final amount. These are just the usual ways that we use increase and decrease in English. If some quantity goes from a smaller amount to a greater amount, it's increased. If it goes from a bigger amount to a lesser amount, it's decreased. The key thing to keep in mind, though, is whether we're talking about an increase or a decrease, the starting amount is the base for the percent change. It's not necessarily the smaller value, not necessarily the larger value. It's whatever value we started with. So if, for example, suppose that we know that the population of a small town was 15,000 in the year 2000, and it had fallen to 13,500 by 2010. And we want to know what was the percent decrease. Well, our first step would be to find the amount of decrease. And to find that, of course, we need to subtract what we ended up with from what we started with. So the amount change was 15,000 minus 13,500, which is 1,500. We can then find the percent change, the amount change over the starting amount. What was the starting population? 15,000. And that should be the unknown percent change over 100. What do we do now? Well, I see some super duper low-hanging fruit to simplify this fraction. I'm going to cancel some zeros before I start, just to make my problem easier. Now what do? We cross multiply, get 15 times 100 is 150 times p. So what do I need to multiply 150 by to get 1500? Maybe you can see just by looking that this is going to work out to 10. Or maybe you'd like to write this out. 150 goes into 150 exactly once. Nothing left. So when we write out the division, we do in fact get 10. What is the percent decrease? 10%. I'm going to give you one of these to try. Remember to decide whether it's an increase or a decrease. Suppose that yesterday gas was $4 a gallon. Today it's $3.85. What is the percent change, and is this an increase or a decrease? Pause the video and try this now. Okay, so second question first. If it was $4 yesterday and it's $3.85 today, that means today it's less expensive. So this is a decrease. And now we just need to say a decrease of what percent? First we need to find the amount change. It's the starting amount, $4, minus the final amount, $3.85. Why did we need to add zeros to the right of the decimal point? Because we want to do subtraction. 0 minus 5, can't do it, have to borrow. This place doesn't have any, we have to borrow from the 4. So we'll have a 10 in this place. Borrow from that, we get a 10 over here. 10 minus 5 is 5. 9 minus 8 is 1. In addition and subtraction, the decimal point in our answer goes right underneath the decimal point in the two numbers we started with. So now we set up our proportion. The amount change, 15 cents, over the starting amount. What was the starting price? Starting price was yesterday, $4. Is our unknown percent change over 100. So we cross multiply. Multiply 0.15 times 100. We can either think move the decimal point 2 places to the right, or we can think ignore the decimal point and multiply, and then place the decimal point so there are 2 digits to its right. Either way, we get 15 is 4 times our unknown percent change. The percent change then is the missing thing in a multiplication problem. It'll be 15 divided by 4. Writing out that division, 4 goes into 15 3 times. I could stop here and say 3, and then the remainder is 3, and those are quarters. I could say my unknown percent change 3 3/4%. Or maybe I like decimals and I'd like to keep going and get one. I'll add a 0.0 to my 15. 4 goes into 37 times because 7 times 4 is 28. Subtract and get 2. I'll need another 0. 4 goes into 25 times with nothing left. So this is also 3.75. I could also say a decrease of 3.75%. Either of these answers would be correct.